the nation prayed for his survival. Little Prince, then 4 years old, would become India's biggest breaking news subject.
But rocky terrain is posing a terrifying challenge for the rescue teams. It has hampered the drilling process, which is why it's taking more time than usual.
Everybody put very good effort, but despite that, because of one or two major glitches, actually we couldn't rescue the child.
In India, recently we have witnessed some of the most tragic and helpless incidents where many young lives have been taken due to falling into borewells. Borewells are typically small in diameter, ranging from 4.5 inches to 12 inches. India is the biggest user of groundwater in the world and has over 27 million borewells meant to extract water. Once the water dries up, the motor and the PVC pipe that is inserted along the depth of the well are removed, while the outer surface is not covered properly. Children playing near these abandoned borewells happen to fall deep into them. As the statistics suggest, in the consecutive years starting from 2009, more than 40 deaths have occurred while being stuck in borewells. The most mournful fact is that 92% of these victims are under the age of 10. This distress situation still continues despite all measures taken. The rescue process to save a child from a borewell is long and complicated. An incident was highlighted in 2006 where a 5-year-old child named Prince was rescued by the Indian Army after a tough combat that lasted 49 hours. Statistics reveal that not many kids were as lucky as Prince. An incident in Indore took place in the same year where a child named Deepak was stuck in the pit hole and died due to the lack of oxygen. The rescue mission is dependent on various crucial factors such as its location, diameter, depth of the borewell, availability of digging equipment, oxygen, lighting facilities, and the nature of the soil. The conventional method involves a parallel hole that is dug to the depth of the borewell in which the child is, and a horizontal hole is subsequently dug to connect the two vertical holes. However, this requires considerable resources in terms of rescue workers and heavy machinery. In the absence of any equipment, this leads to the failure of the operation. These methods are time-consuming and are often delayed if, while digging the parallel hole, the diggers strike a hard rock. Such exigencies affect the chances of rescuing the child alive. Also, because of the lack of oxygen and deathly atmosphere, children die slowly before the rescue team can reach them. First, the depth at which the subject is stuck is measured, and according to that, ropes are arranged to send the system down. The diameter of the borewell is then measured, and according to the diameter, a rod is lowered within a channel made by the locking slot of flaps of both the arms. With this locking mechanism, the flaps will fold when it reaches below the subject and prevent further falling of the subject. A liquid supplement tank is also filled before deploying the system. After completing the initial setup and taking all the necessary measurements, the system is sent down with the help of ropes. A gyroscope informs the operator of any deviation and helps to maintain the balance of the system. A camera and lights give 360-degree coverage throughout the operation. The camera helps us to detect the space or gaps that we can use and align the device with these spaces. After acquiring the right depth, a double-acting telescopic hydraulic cylinder extends with arms on both sides according to the diameter of the borewell, without creating any disturbance which might increase the risk of collapsing of the walls of the borewell. Then, a slider mechanism sends the arm from those gaps below the subject and the strings are pulled, which closes the flaps, hence preventing the subject from further falling inside the borewell. Now, the reinforced fabric is deployed, which acts as a shield against the surface of the borewell. It encloses the subject into an envelope, hence protecting the subject from toxic gases present inside the borewell. Now, oxygen is supplied to the subject. After the fabric covers the subject, the system is pulled out together with the subject. A double-acting telescopic hydraulic cylinder is used to control the arms of the system. It has a 3-stage mechanism that reduces the mounting space required for the cylinder. The pistons, when extended, will have a size of up to 10 inches and 4 inches in the retracted state. The hydraulic system acts as a cushioning mechanism on both sides to help reduce the pressure exerted on the walls of the borewell. The flaps are made up of folding links with a locking slot which allow them to fold according to the diameter of the borewell. A rod is lowered within a channel made by the locking slot at the time the system is prepared to be lowered. When the arms reach below the subject, the strings are pulled, which results in closing of the flaps, thus securing the subject. The length of the arm is 6 feet and can be lowered as per the height requirements of the subject. The reinforced fabric acts as a shield against the surface of the borewell, which prevents friction injuries and also ensures that the subject does not fall further down. The fabric is made up of a strong and flexible composite material which is reinforced by steel wires that act as a hard shield when it is closed by tightening both the ends. It also provides protection against falling debris. When the subject is enclosed in the fabric, oxygen can be supplied to the subject in an effective manner, and it will also protect the subject from toxic gases which may be present inside the borewell.